Okay, another implicit differentiation. We call it implicit because the y is entangled with the x. It would be difficult, possible but difficult, for us to solve this expression for y. And so we're just going to leave the x's and y's in combination like this and try to do the derivative anyway. So, one term at a time. If you're doing 3xy, I'm going to treat 3x like my first piece and y like my second piece. And I have to think of it that way because this is a product, which means the product rule applies here. So I have to do first d second plus second d first. First part is 3x. Derivative of the second part is the derivative of y, which is simply dy, plus the second part is y. The derivative of 3x is 3 dx. Fair enough? First d second plus second d first. No derivative, when you're in this mode, no derivative is complete until you've written d something at the end of it. Well, unless it's 0, in which case the d gets wiped out too. So, but every non-trivial term ends up with a dy or a dx on the tail end of it. So that takes care of this part. On to the next term. One variable here, so we don't have to do product or anything, but we do have power rule, and we're going to get minus 4 y to the 1 dy equals the derivative of 5x is 5 dx. All right. First d second plus second d first. These two terms only had one variable, so there was no product or quotient or anything like that. It was just power rule and simpler power rule. Now, we want dy dx out of this, and so we now divide the whole works by dx. Every single term gets divided by dx. And the result of that is, in two terms, dx's just cancel, and they're gone. And we have two terms which contain dy dx, which is the thing we're trying to solve for. So let's get this cleaned up a little bit. We have 3x dy dx plus, this is y times 3, I'm going to write that 3y, minus 4y dy dx equals 5. If we're going to solve for dy dx, let's get it alone in the equation. So I want to take this 3y to the right-hand side. So we're going to have all our dy dx's on the left and all our terms that don't contain dy dx on the right side. We're going to segregate the equation. 3x dy dx minus 4y dy dx equals minus 3y plus 5. Okay, so we have a dy dx side and we have a no dy dx's side. It's not good that this occurs in two different places, but that's easy to fix. We can factor it out. If we factor out dy dx, we get dy dx 3x minus 4y equals negative 3y plus 5. And now, if we want to isolate this, we must simply divide by 3x minus 4y. So, do that. And same thing on the right-hand side, 3x minus 4y. And when it's all over, we have dy dx, the derivative, equals minus 3y plus 5 over 3x minus 4y. Took a few lines, but nothing too bad, right?